Hey everyone, welcome to Build.
Uh,
Hey
Hello.
there. Let's
Yes.
talk a little bit about C Sharp. I'm Mats Torgerson. I am the lead designer on the C Sharp programming language.
And my name's Dustin Campbell. I'm an architect in all sorts of things in the .NET kind of developer experiences, and also a member of the C Sharp language design team.
And
So
we're here to talk about C Sharp, both in terms of what's recently been shipped in C Sharp 8, but in particular, an early look at some of the nice things that we're going to put out in the next version of C Sharp, which we're predictably calling C Sharp 9. Um,
that's excellent. I'm glad we're being consistent
right
again.
there, we're sort of just counting
Yeah.
up every time. So
In a way, it's a letdown, but in another way, it's very
yeah,
comforting.
we
So
should find a really snazzy name one time, just surprise everyone, calling it C Sharp Starship or something.
exactly.
But that won't be this time.
Yes, C Sharp
Yeah,
Starship.
right.
Yes.
Oh, that's so 70s. So we do actually. There's rhyme and reason to how we think about putting new stuff into this programming language all the time. We have what we call the C Sharp language strategy, which you can find at that website, which is partly blocked there on the screen. So
Scared by your floating head.
yeah, right. So there's a couple of core things there. It's a lot more explanation if you go and look there. But essentially, what we're about is we want to aggressively evolve and innovate in C Sharp. Like we really want to keep the language moving with the changing developer landscape, the changing domains and tasks that you have to solve with programming. They have to be as natural and as convenient in C Sharp as the things you did when we came out 2 decades ago. So it's really important that we not just, add new features that other languages have, but also we're very active in innovating and being state of the art there. Um, it is a language that's being used by very many developers for very many different things. And so it's important that the things that we do in C Sharp, by and large, benefit everyone. They can't be too much for specific scenarios. There are a couple of places where we make some exceptions to that. In particular, in recent releases, we have put more things in that are for sort of what you could call low-level or systems programming. And that's because we think it's really important that more of those things further down in the stack, if you will, are written in a safe language. And also, it benefits all C Sharp developers indirectly in that the frameworks that you built on are safe and efficient. So we've done some things there that you might not use the features, but you'll still benefit as a C Sharp developer. And then finally, we've been very eager to engage with the community. Obviously, since we went open source, that there's been an explosion of dialogue around what the language should do, and that gives us an incredible amount of signal as to where to steer the language, as well as just good ideas and feedback on the details of what we do. Um,
And even features, implementations and things like that as
yes,
we're
so
open
that goes
source.
both at
It's been
the coding
fantastic.
level and the
Yeah.
compiler, and also for the actual language design, which is also in and of itself open source. At the same time,
Yeah.
we want to be very careful that we don't end up in a design by committee situation where everything's done by vote by a community or something like that. Because I think it's important that a language has strong stewardship and has sort of an approach to staying with a unified vision and a coherence of the language. And so we do that by having a language design team that makes all the decisions around the language. And both of us are on it. So, of course, we think that's a good idea. So
Yeah.
that's really sort of the driving mission statement, if you will, that has us going back year after year to the drawing board and saying, what's the next important thing that we can address at the language level? Now, you're going to see most of this evolve and innovate today because we are in a talk about new language features. So let's quickly
Hmm.
go over more sort of in repetition form. Many of you can find more detailed talks about C Sharp 8 out there, but let's go over the main things that we added in C#, and that came out about 6 months ago as of this recording, in along with .NET Core 3.1.
Yeah, this is C# today and tomorrow, right? Is the name of the
This is
talk.
the today.
This is the today.
Yes, this is what you can go over
portion.
and do in the product right now.
Yeah. And this is an extremely long presentation, and very soon we'll be talking about tomorrow.
Yes, C# tomorrow.
So, no.
Start watching this at 1:45, and then it might just turn out to be true.
Yeah.
But then it'll be today. It'll be very confusing. So I have a little snippet of a program here that happens to showcase most of the features that were put into C# 8, apart from one that has a different snippet in the end. So I guess the biggest one in terms of developer impact is the smallest one in terms of syntactic impact, which is nullable reference types. So we added this ability for you to express that a given reference should be able to be null or not by optionally putting a question mark on the type of that thing. So now you get diagnostics when you're not behaving the way that was specified. If you put nulls places where they shouldn't go, or if you dereference things that should be null, or that could be null, without checking first, then there's this whole new regime of compiler feedback in terms of warnings that just helps you get this right from the beginning as you're coding, rather than having to rely on test coverage in order to, or customer reports, in order to find those null reference exceptions. So that's a big one, but with a surprisingly small footprint on your actual code. Right? It's just a few question marks here and there, and exclamation marks, which I haven't shown here. Okay.
No, that's fine.
Async streams. Async was a big deal when we added it about a decade ago. It was really a feature that spread throughout the industry and many other languages, including now JavaScript, has the async await feature, which started out in C#. But we're sort of, it's sort of a crusade to get rid of callbacks and the insanely difficult coding situations that you get yourself in when you have to deal with callbacks, like error handling and all that kind of stuff. But we weren't really still good around callbacks when it came to streaming data as opposed to individual values. And this really takes the next step, where we have a concept of async streams. The iasync enumerable type has been added to the framework, and we have language support for reaching over streams of values that are only individually produced asynchronously. So await for each here, and you can also produce them with async iterators, which I haven't shown here. Now, also very small on this slide, some very convenient additions to how you can index into various data structures, including syntactic support for ranges, which let you index with, you can index with a range like the open-ended range 2 ... here, that is essentially a slicing operation. So you go to your arcs and you say, give me from element 2 and onward to the end. So this lets, whenever you're dealing with arrays, or very importantly, span of t, for instance, which is a type we talked a lot about earlier on with C#7, that helps represent sort of references to sequences of data. It's very nice to be able to slice and dice those with convenient syntax.
Mm-hmm.
Now, we also did a lot in terms of around pattern matching and that kind of logic. We added an expression version of the switch statement called predictably switch expressions, which look like this, where you have sort of a fluent kind of syntax for tacking a switch onto the end of some expression, and that switch will then go from cases to results with a lambda arrow in between. So it's a very compact way of representing a switch where every case needs to produce an output value. And along with that, we extended also what kinds of patterns you can have in pattern matching, which you have in switches and is expressions and so on around the language. In that we added recursive patterns that can have other patterns in them by, in this case, deconstructing the value that's coming in. The customer is being deconstructed into two values that represent the first and last name with the parens there, and then patterns are applied recursively to those individual elements of the customer. So that's pretty much it. There's one more thing, which is also quite interesting, but which is a little more sort of in the programming in the large parts. So we have a different example for that, and that's with default implementations in interfaces. So as of C#8, you can actually provide a method body for an interface method. And so there's an example of that here. The reasoning behind that is, to some degree, of course, it's convenience. There are some interface methods that almost always are implemented the same way, and wouldn't it be nice if I could just provide a default implementation for that purpose? But I think the bigger purpose is one more of software evolution, where this lets you actually add more things to an interface over time. So this interface, iLogger here, could have started out with just the top log overload, and now we can add another one as long as we provide a default implementation without breaking that existing implementer below, the console logger, that are not providing an implementation for the second overload because they didn't even know it existed when they were written. But they don't have to either because there's a default implementation they can pick up. And so interfaces are kind of becoming unlocked from stasis, if you will. They can now evolve over time with this mechanism.
Yeah. And what's super cool about that, what I like, it's not represented as well here, but you did allude to it, that you could implement that second method that has a default implementation, right? If you wanted to do something further with it. I like this example because you might have a different way of logging an exception. You might say, now I'm going to send that to some, telemetry backstore somewhere where, okay, an exception occurred and I want to log it a little bit more significantly, maybe capture a crash dump or something. I think it's not just that it's like you can evolve the interface, but also you can kind of provide optional members for that people can optionally implement, which I think is super powerful.
So that's all we want to say about C#8 today. Again, you can find very detailed information out there because it's actually shipping and it's in broad usage already, has seen quite a lot of pickup. One note to end on is in particular with nullable reference types. That one has been a feature that in its very nature, it sort of needs to propagate across the ecosystem, if you will. You can't really benefit from it completely until the things that you depend on are starting to use it. Until the API that I'm calling into has annotations about whether you should give it null or not, whether you can receive null or not from it, you don't get full checking of your own code. So it's been very gratifying to see the uptake kind of spread throughout the ecosystem, and more of the APIs that other people rely on, more of the libraries out there are coming online with the nullable feature and offering up this additional detail, essentially this additional type system detail to its consumers for them to choose to use when they're ready. Okay. Yeah. I think that with that, we should crank the number up and talk some about C#9.
Yeah. Very satisfyingly move it up to C#9.
So this is work in progress. Yeah. C#9 is not finished yet, and even the features we show you we're pretty certain about their overall design, but even their syntax may evolve and change, and That's part of the reason why we show it actually now, is so that we can get that kind of broad feedback that lets us make the final adjustments and decide, that keyword should be different, or the ordering of these things should be different, or that feature wasn't actually as cool as we expected. We've been known to yank things up until the last minute, so no one should feel safe.
Yes. Yeah.
So the plan is for it to ship with .NET 5 just a year after C# 8, which is a short cycle for a major version of the language. But there's actually a lot of stuff in there. We've just been working really hard. And so we'll see some of the stuff that's in there, and you can go and look at more in the resources we'll provide at the end. Two themes that I think they're by no means exclusive, but they're sort of key to especially the features we'll be showing. One theme is simplicity. Just make things simpler. Just make code easier to look at in common scenarios. And another one is a continuing focus on data and immutability. We've sort of been, C# is rooted in object-oriented programming, where things are very encapsulated and self-contained. And we've been working for years to balance that with being better at handling data that needs to be more, where sort of the data values are quote unquote dumber. They do less on their own and more and are more being manipulated from the outside. And along with that, we're seeing a rise in the interest in programming with immutable data, and that has always been at a major disadvantage in C#, even though we made some strides along the way. And we're trying, with this release in particular, we're doing a lot to help with immutable coding, as you will see shortly as we go and actually demo some stuff that's in demo time.
Demo time. Excellent.
So here you have, we're over to Dustin's screen.
All right. Yeah, so this is actually the final state of last year's build, one of last year's build demos, where we were talking about pattern matching. This code had some pieces that we wanted to refactor and apply some of our newer patterns, because one of the things that's really started with various, some of these features over the years is that we've introduced features in a particular version, but it wasn't really completely done. We had more to say in future versions of C#. Mads was reminding me about Async earlier. It started in C# 5, and then later we've done all sorts of things with Async, like async streams or adding async main, things like that. And pattern matching is one of those features as well, where we've continued to evolve pattern matching, adding recursive pattern matching in C# 8, even though the feature itself was introduced in C# 7. Also things like property patterns and various other things that we updated, we showed last year, and this, some of the fruits of that labor are in this demo that you see here, this code. Where we'd had this, it was basically an application that would do toll calculations for crossing the 520 bridge here in the Seattle area.
And I do want to...
Now, we have some ideas, though.
I just want to point out that this example is also one that is available on docs.microsoft.com. It's one of the major examples that's used to explain pattern matching. So you can go and grab that code easily there and play with it.
Yeah, this was provided to us by the great Bill Wagner, so thankfully, and so we're going to make it better this time, Bill, and it'll be even nicer on docs.microsoft.com. So some of the things that we kind of left behind, though, we had things that we wanted to do and we couldn't do yet because the language wasn't there to support it. I'm actually in a build of Visual Studio 16.7 preview that's been released here at Build, that you can try these features out on. These are C# 9 enhancements to pattern matching that we're already out there in the wild that you can use today. So the first thing that I kind of like to point out is we have all these different cases, right? We're checking cars, we're checking taxis, buses, and delivery trucks. Now, and the point here is to calculate what kind of the basic toll would be for those vehicles. Now, the way we did these pattern matches is that we matched, like on a taxi, various fares, and then we have kind of a catch-all here. And we always have to use this underscore, which is kind of annoying. And it's annoying in general with pattern matching, is that like if I'm testing a type, I always have to put a name there. And so we kind of thought, what if you didn't have to?
Yeah, we sort of make you
Right?
say that you
That's
don't need a name. Yeah.
yeah. Like, please don't give. I swear this does not need to be named. Instead, how about we just let you omit that? And that is new
Yeah.
in C
That's
Sharp
just a
9.
simple type pattern now.
And the crowd
Yeah,
goes
right?
wild. Right?
First we
Yeah.
introduce
So,
discards everywhere, and now we are even letting you not
yep.
say them. So.
Yeah. Yeah. Um, so, and that of course works equally in a regular switch when you're using pattern matching. It's a new pattern. Um, Now, another place where we found something that we could not really do much with in the version that we were using at the time. We did some really nice pieces here. I loved this where we said, day of week, Saturday or Sunday. Otherwise, it's true. Just to tell whether it's a weekday. It's a nice pattern match there. But we couldn't really do anything with this because this block is just a bunch of if-else's, but they're relational kind of expressions where they're asking, okay, it's trying to figure out, are we overnight, are we morning, are we day, by checking the current hour. And so we couldn't really do anything with this. But today, or tomorrow, I guess, we can do this in C# 9, where we've added relational patterns that allow us to, and the IDE supports it already, allow us to instead just switch on relative to, switch on with a less than that, treats the left hand side of that being what's being switched on, and then the right hand side is there. So you can do a really nice, beautiful, succinct pattern here that I am super happy about, because that means we kind of get to finish the story of these particular functions. And then now I don't need any of this extra boilerplate code, and I can just turn that into a nice switch, nice expression body member.
That is super
and
nice.
That's really pretty.
And just to be clear here, what happened here is that we have a new kind of pattern, which we call a relational pattern. So the less than 6 there, that is a pattern that matches ints that are less than 6.
Yeah. I really wish the IDE would let us
sort of a tabular
line things up
formatting.
Like that. It doesn't. Yeah.
Yeah,
this is officially a request for that feature. If GNU's listening, that's what I want. Cyrus, if you're listening, this is what I want. All right. But that gives me an idea, though, right? Because we were able to use these relational patterns down here, and up top we have several places where we're also doing relational kind of faking out relational patterns by using when clauses, right, on these cases. And if we are to break this out a little bit, and we could use some of these relational patterns, just like we have down below. So I'm going to do this with delivery truck, okay? And I think the way to start this is that what we really want to do is we want to match on that gross weight class right here. That's what we actually want to be matching on, because we're checking this both times. We're checking, is it greater than 5,000, or greater than 3 or less than 3,000. So what I'm going to do is I'm going to use a nested switch expression, kind of like what we've done with cars up above. And so I'm just going to match on delivery truck of T, and then I'm going to put an arrow in to indicate that, okay, this is now a switch, this is now a condition, another case in the enclosing switch expression, and then I'm going to match on T gross, or switch on T gross weight class like that. That's what I want to do. And right now these are all errors because these patterns aren't reachable, because I have a pattern here that subsumes them all, right? But now I can take these particular cases and just move them in here, just like before. And we have this relational pattern right there, and I could change the order on them so they look right. This one I have to put a discard in this one right here, and that's good.
That is very pretty. It seems kind of a shame, though. They're not. You put them more in order, but the last one sort of belongs in the middle, right? It's the one that's greater or equal to 3,000 and less than or equal to 5,000. So, but we still have to put that at the end.
Yeah. What is my code?
No,
I
want more.
For you, man? Okay. Well, if we move it up, the problem is that if I move it up, now, just like we had before, this is going to subsume this case. right? So I can't do that exactly. Um, we would need
Hmm.
something more here. Um, Fortunately, we do have that, and
Of
obviously,
course
I'm
you
just
are.
playing games with you,
And this is a big surprise to
or
me. I
something
didn't know
else.
about this
But I
language
could.
feature until
This the
until right
You
now.
didn't know. You didn't know. Woo! So we could say, use the relational pattern and say, okay, we could say that we want to be greater or equal than 3,000 to be in the middle of,
Hmm.
these two cases, um, and we want to be less or equal to 5,000. And this is where I really want this tabular formatting, Cyrus, if you're listening. Um, but now that and what's great about this is I don't have an underscore. Usually we use the discard as that final case just so that we make sure that we handle everything, right? But in this case, the compiler knows that we've handled everything. We've handled the entire domain of integers with this less than and greater than, and then this kind of and
And
expression right in the middle.
and
This
the
and
AND
pattern right
pattern.
in
I
the
think
middle.
that what's important to
So
say again, to generalize here, AND patterns are a thing in general, right? It's not just that you can have more relational
yeah.
patterns combined. You can combine patterns in general with um, and we use
Hmm.
the written out, spelled out form to distinguish it from the and or and not that we have in ordinary expressions. But we actually do have all three kinds of, you could call them pattern combinators, or logical pattern
Yeah.
operators. So we have or, and we also have a not. Um,
Oh, that's right. We have
mm-hmm.
not. Well, we could use not in here as well, I think. So right down here we have this again. We have this catch-all, and we just throw an argument exception. We're actually pretty careful in this um, to not catch to just we're catching both things, right? We're both cases where it's something that slipped through here that's not a car, taxi, a bus, or a delivery truck. It could be null, and it's potentially not
Right.
null.
So we.
So what we could do with this
Mhm.
is actually break it out into two, right?
Yeah, just
Sorry, you
that
were about to say something.
we're sort of collapsing the null and unknown cases, or we have been in the past.
Yeah. So in this case, I could have done this before. We did not do this in the previous version of this, and we could have. I mean, we had the null
Hmm.
pattern already, and now it's actually correct. We can change the message slightly here because we know this is not null. Um, so just you know because we've already handled null, and now I can put it in there, and we can get see what the
Right.
object
You could
is
even
maybe into part of the message. But if I want to be
yeah, you could
super
even
clear
safely dot
about
into
this, right?
vehicle if you wanted to, because it's yeah.
Yeah.
But the problem is now it has to
Yeah.
be at the end where you know that it's not null.
Hmm.
But now with the not pattern, you can say
Yeah.
not null in a very that's a very readable pattern in my mind.
Yeah. Yeah, exactly. And so now we have, and if I wanted, I could move these around a little. At least the first one, I could move the first one to the very
Mhm.
top if I wanted to exit out early, or at least, I could exit out early, and I could see that it exits out early, like you often will when I'm checking preconditions into a method. And at the very end, we can say, well, yeah, this wasn't null, and we can be very clear about it. Um, the important thing I think about not null, though, this is maybe a slightly more contrived example. Where it really shines is expression, right? Where very often I'm finding that I'm having to write code that looks just kind of the dog's breakfast, where I'm saying if you know parenthesis bang parenthesis customer is null, right? I'm negating those patterns. Now you could say customer is
Yes.
not null,
Yeah.
for example, and get a really nice, very readable, from a kind of a language, an English language grammatical sort of way. It's very nice. Um,
Yeah. Very cool.
so very cool. All right. So that's what we have to show for pattern matching. And again, that's in current bits that are released right now. They're preview, but it's for 16.7. Visual Studio Preview 1 has bits that
Yeah.
these same
You
bits.
have to use the
And hopefully
yeah. You have to
we'll
use
update
the
that.
preview
Yeah.
lang version when you play with these. But
Hmm.
if you forget, then the compiler will tell you to do it. So it's not as if yeah.
All right. Right. And we just, that's all I did, is add that right here, and it lit up. In fact, if you try and use these things, you'll get an error telling that you need
Exactly.
to set the lang version to preview that they're
It's being
unsupported currently. So
very
it's
helpful.
a pretty decent experience.
Okay, but not
All
everything.
right. Well,
Not
we
everything
want to
is
show
in
something.
preview yet. We have hotter
Yeah,
bits.
we do. We have magma hot bits. As usual, we have bits that are terrifying and have many potential points of failure. It's not as golden path this time. The bits are pretty stable. What's interesting about these bits is, and what we're going to show, is that a lot of it's in active design, right? And so we're going to show things, and they might have different keywords when we're done, and some of that. But we want to show you now some of what we've been working on, and it's good stuff. So I'm going to switch over to another version of Visual Studio right here. And this is a really simple application. Okay, we have a person type down here below, just with public auto properties, and then we have our main. We have our class program, static void main. We create a person, we display it. Here's a local function here to display that person. Right? It's demo fodder of the highest order. We even using static for system console, just to show you that's very much demo code. I'm joking. I'm teasing. But Mads, what I hate about this is that there are literally 6 lines here that are just ceremony. There's more than 6 lines that are ceremony, but there's 6 that are especially egregious ceremony. Can you guess which ones I
can
mean?
because I read the demo script. but
yes, of course.
I think that
of course. But could you act like
what?
you didn't
Okay,
answer?
so maybe is it all the white space?
No, it's not the white space. That makes it worse. No, it's this class program, this static main. I mean, we always have to say this, and it's just laborious. It's the first thing if you're in a class learning C#, that's the first thing the professor says. Yeah, don't worry about that. Just move on to the next thing. They say, what's this class? Just don't worry about that. Why is there a static void main? Don't worry about that. Next, they want to get you inside the main method where you can write code and you can get the power of actually making things go with C# as opposed to making the compiler happy. And so what I'd like to be able to do is to just delete these. And in this build,
you can.
I can. And I will compile and run, and we should see eventually, as it spins up, there we go, that in fact
it works.
It runs.
So now you can just write
works.
source code. You can just write statements at the top of your file in C#. We call this feature top level statements.
Top level. It's a very creative name, but it's about letting a simple program, remain simple, right? And allowing you to just say, well, I don't really need the ceremony here. I'm just writing my main method, and I'm going to write it just naturally at the top level. The interesting thing about this is it does have some ramifications. That means that this isn't a function that's global that can be called by anything. It's a local function in the main method, right? It's still a local function in the main method, but I can call it within my top level statements. Also, we're not interleaving kind of the main method at all. I can't write down here. I could write if I wanted. But that's in fact an error, because top level, and the error shows me that top level statements must precede namespaces and type declarations. So once you write a class or a namespace, that's the end
have to
of
go
your
in
main
between
method.
the using stuff, that sort of preamble, and the namespace and class declarations, and it has to all be in the same file. You can only do it in one file in your compilation. So it is really just my program goes here. You get to put it right on top, but only in one place. It's not like a fancy feature that tries to weave things or nothing like that. But that's not what you need.
We don't have to worry about file order to stitch them together and all of that. I mean, the Solution Explorer today is sorted, so that would be a very bad problem to have now.
So from now on and for the rest of our lives, when we demo things in C#, we will not have a main method anymore. We will just write lines of code at the top of the file. That's really awesome.
Yeah. As soon as this ships, unless we're in async main, I promise you that this will be how we start our main
Right,
methods.
and this works for async as
So,
well. You just use a wait. You just put a
oh, does
waits
it?
in
I
your
didn't
top
know
level
that.
statements, and then it'll
Oh,
become an async main. And actually,
well then let
that
me correct myself. We will
right.
never do this again.
And actually, this is not implemented yet, even in the Magma Hunt bits we have. But actually, the plan is to also
Yeah.
allow args as a magic keyword. Um, we we know
Yeah.
that the args argument to the main method doesn't have to be called args, but in 99% of the cases, people will call it args because that's what the templates put in, and that's sort of the standard. So we will actually make a variable available in this top level code called args. It's just like it's a magic variable, just like the or magic parameter, you could say, just like value in a setter. That is just
Yeah.
in a
On a
property
property
setter.
setter. Yeah.
So so
Makes
that
sense.
you aren't limited in what you can do in here compared to what you can do inside of a main method.
Cool. This is an awesome feature. I'm really
Yeah,
looking forward to this. So, at least in one
yeah.
file, I'm looking forward to it. Now, now let's talk a little bit more about. We said we want to talk about
Mm-hmm.
data and mutability, and how we're trying to really help with that in C#9. And I've got this person class, and just for the convenience of being able to use an object initializer to construct this class, I have chosen to make these mutable properties with a public get and a public set. That honestly, it means that you know, bad things can happen, right? Some nefarious person, I don't know who would do this, but some nefarious person could walk up to this and type something just awful and change the meaning of the program, mutating the object
Right.
after the fact. I don't know who that would be, who would ever do that. But
Yeah, yeah.
but yeah, so
So the
that's
point being that it's the, you, relying on object initializers is awesome when you're declaring the class. It's awesome when you're using it, creating it, but
mhm,
it is strongly tied to the class being mutable because it uses mutation to actually assign the first name and the last name in this case from the object initializer.
yes. Yeah. So we do have a way to
Mm-hmm.
address this now, right? Okay. And this is about the idea of making properties that can, the problem is that if I want a read-only property, then that's only settable in the constructor, right? And object initializers break down into a construction of the object and then a bunch of assignments after the fact, right? So I can't do this because it's only settable within the constructor. But an object initializer has this, it's just this wonderful concept of I'm not only constructing my object but I'm initializing it, and it's bounded by these braces, and so it feels like I should be able to have a property that is is basically settable within a constructor but also settable within
Yeah.
initialization as well during that
Yes.
period of time. And so I can do that by using an init-only property.
There we go.
Yes, and now this nefarious activity is thwarted because an init-only property or indexer can only be assigned an object initializer or this or base. Hey, it's another one of these compiler messages, but it's very clear. You can't
Yep.
do this here. Is what
You
it
get
means, and
to
so
you get
we
to
say no to
change
that.
these only in the object initializer as you're creating the object as part of the new object syntax. And after that, it's no
Yes.
go. So you have an immutable class that works with object initializers.
Yeah,
That's awesome.
and that's beautiful. That's beautiful. And this is just a general feature that you can use on any class. You could have an init-only property if you want to set things up like this so that there's some level of protection against, you're in a you have a big project and you want to guarantee the state of those objects, and you never know who on a big team is going to grab something and do something bad with it. You never know. It's best to protect against those things or against your future self, because your future self is always always forgets what your
Right.
previous self did and intended. So that's what we have here. This is a fantastic feature, but we can do more with this now. The problem comes here when I have immutable objects. I often have immutable objects where I want to now treat them different. I want special features on these. We've talked about this before, Mads. I think you've mentioned it in a previous build talk about destructive mutation, right? Where I want to be able to, basically take some type of immutable data, and instead of setting the data, changing the data directly on that on an instance of that class, instead I want to be able to create a new instance of that class where all of the data is copied over from the previous instance of that class, except for these changes.
Yes.
Right. We do this a lot in Roslyn with our syntax tree model, where we've got, we put lots of little with methods on there. And so we have an answer to that in C#9. We want to be able to, take those with methods that, this kind of a general pattern that people are using, and just bake something into the language that makes sense.
Yep.
Right? For immutable data. So I'm going to change this class. It's no longer going to be just a normal class. Now it is a data class, and this is a keyword that is the keyword that happens to be in the prototype. It is up for debate and up for change, but this is what we're calling a record.
Yeah, and so record is a lead contender for that keyword, but currently it's data.
It is a lead contender. Yeah, currently data. And this now kind of bolts on several features to this class, several qualities now to this class that give me more ability to play around with it. One of those is that destructive mutation that
non-destructive rather.
About. So instead of
yes,
what's that? Oh, non-destructive. Excuse me. Sorry, you should have corrected me before. I was just out to lunch. And the idea is that instead of changing the data directly on that object, I want to get a new object with some changes to it. Okay, and so now I can just create a brand new version of this. Thank you, IDE. Again, Magma hot bits. Lucky didn't crash. All right, so I'm going to run this, and we should see that the original person doesn't get changed. Right now, there's a new one that has.
That is awesome. That is exactly right for these immutable coding styles or paradigms, where you modify the data by creating new versions, and the old ones can still be around. You can even diff them, or this is used for all kinds of things, for rollback and keeping track.
You can diff them. I mean, because they. Yeah, I mean, but you can. Some of the diffing happens because they have they also have different kind of equality built in, right? So, for example, if I want to say, like, let's create another person based on the other person. Whoops, I need that with keyword, don't I? My fingers don't automatically type it yet. And then say I wanted to set its last name, the last name of this person, back to Hunter. Well, what's interesting about that is that, and let me go ahead and we'll display this to the console so we can see it, but I also want to display to the console, I'm going to write out the value of calling equals on this between person and original person, because one of the qualities of a record is that they have value equality, which means that if their parts are equal, if their data itself inside contained within that instance is equal, then it is considered, between another object, if it's the same, we consider those equal. But they are not, in fact, the same reference equal. So they are not reference equal, meaning they're not actually the same instance, but they are considered equal by the values within them.
Yeah. So this is this thing where they are still. We still want these objects to be reference types, so that you can build data structures with them. You can build trees and whatnot out of them. They can't be like value types like structs necessarily, but you want them to have value semantics in the sense that what's inside of them that's important, not their object identity.
What's inside of them that's important. It was a lesson we learned was inside of us all along.
Yes.
I think
it's
sorry.
Beautiful, really.
It's beautiful. And so if I run this, we'll see, the original person and the other person, and then well, not the original. We'll see person, other person, and then we'll see original person, which should look like person. But then if the value semantics hold, we should see true
Mm-hmm.
and then false, right? So I'll go ahead and run this, and that's exactly what we see.
Yes.
And you can really drill that home if I go ahead and change that name, then you'll see that now it's not value equals, nor is it reference equals, of course, because it's a different instance. So this is extremely powerful stuff. I'm kind of in love with this ever since we started working on this demo. So
it's a lot of the like us having written the compiler framework Roslyn in this style manually. We know it's a lot of heavy lifting to get these things right, the equality and the withing, and it just the value semantics really, and that is why we realized how important it is to build it into the language.
Yeah, it's especially challenging for cases where records have a long history, right? In functional programming, there is a well understood notion of what kind of a record does, but as we bring it to C#, which is an object-oriented programming language first, and it's a general programming language. We don't want to create features that don't feel like C#, and records were one that had some challenges for us because with classes, for example, in C#. We allow inheritance, right? So we want to, as we do this, and it's not in the prototype.
We have some slides, so we'll come back to that point.
Right? We'll come back to it, but we want to be able to, make these very powerful records that work naturally within C# in the ways that you expect.
Now, I have a silly request, which is that in other languages that have record features, they're shorter than this. Even shorter.
Yes, they are.
Can we do something about that?
We can. Now, first off, I'm just going to, remove all of this goop, because yes, in other languages there is a shorthand way to give kind of the public members of the record, right? And this is nice because, and by the way, obviously this is not implemented yet in the prototype because there's errors everywhere. But this gets some really nice one-liner kinds of looking classes where you can just define it in terms of the data. You can put other things in here if you like, but if you're just putting it in terms of this data, then you can write it very succinctly.
So just to understand what's going on here, we're essentially hijacking what's the default for when you just say type and name. Instead of that being a private field, it actually is just shorthand for having a public init-only auto property with that type and name. So you have to understand that you have to sort of accept that when you put data in front, when you make it a record, you change the defaults because we think that the vast majority of data should be public and it would be a property and it would be init-only, and so we want to make that the default rather than the encapsulated fields that you are rarely going to be using in records. So even though it feels a little unfamiliar that this is the meaning of these, we think that this is the right way to go for just capturing the common case. And if you want field, you can still do it. You can just add an accessibility explicitly. You can say private explicitly, and now you're back to a field again. It's just like when you leave out the accessibility, this is understood to be a public init-only auto property.
Right.
Though not in this prototype.
But soon.
Not when they're in there.
Now, we do have another way. Yeah, we do have another way of writing a very succinct record that, also introduces the notion of basically order to the data, right? Where, right now this is what we would call a nominal record, where we've got you can very easily just define your data as members, and they doesn't really have any order, and that actually works very nicely with inheritance, and also will allow you to construct with an object initializer, because object initializers also don't define an order, right? However, I can declare this a little bit differently by introducing kind of a pseudo parameter list up here that defines my properties for me like that. And now I have a very short, what we call a positional record, right, where the data itself is ordered. And if I come up here, now I can't create this with an object initializer because the data is ordered, right? I couldn't, do this, right? Even though it would normally be available to me.
Because that
I have to, whoops, I gotta do it that way, sorry. I have to put the
Right.
values, because what we've done is we put a
Yes.
constructor up there, right? I have to actually put the values up here.
So essentially, we moved the member declarations into that parameter list, and it simultaneously defines the public members themselves, a constructor for the and a constructor for the object, so that it has a positional interpretation. So this is really good for, let's say that you have tuples and you want to grow them up to become named types. You can very easily just
Looks
yeah,
just
just
like a tuple right here, right?
slap a name in front there, and now
Yeah,
you have a name to tuple in essence. Well, not quite, because it's not.
yeah. Not quite, because it's immutable and it's a
Yeah, but
reference type, but but the idea of growing that data up into, but that might be what you want as
yeah,
you grow up outside of a method body. You might want to, have data that is now, well, it's immutable. It's not going to be changed around. I'm going to be using it asynchronously. One of the value of tuples being structs, mutable structs, is that I can pass them around asynchronously because they're copied. They have those copy semantics. Um, and but to do that kind of with a class, I need to simulate that. I need to have an immutable type so that I can pass it around safely as well.
right.
It's more about how they're used than what they are under the hood. Um, Now, because the data is ordered by this constructor, this parameter list at the top, this gives us another feature for this record that we couldn't put on nominal records because we didn't have the ordering, right? And that's that these automatically get a deconstruct method. Again, bringing them closer in line with how you might use a tuple. So now instead of in display person here, instead of accessing person multiple times and accessing the properties, I could just deconstruct person into local variables because it's given a deconstruct method that pulls out those properties and just use them here. And there we go. And now if I run it, everything still runs as it did before, right? We're just moving around code using features, powerful new features of records. And that's what I've got to show in demo today. That's the prototype we have so far. And we are, like I said, we are in active design, and this is going to continue to evolve over the next, few months, and we'll be delivering it in C#.
Excellent. So really, to summarize, there we have nominal and positional syntaxes on the same. It's the same language feature, right? We have records, and you can optionally get constructors and deconstructors on top. And the thing that we touched on along the way is, well, how does that work with the sort of one of the key features in an object-oriented programming language is inheritance. And very often you want to describe families of different kinds of data. And in a functional language, you might do that with a discriminated union, which is essentially sort of like a collection of different records with a shared wrapper type around them, if you will. In an object-oriented language, you are used to describing this kind of thing with inheritance. And that's what we think you should keep doing. We may add further shorthand syntax in that direction in the future for quote-unquote discriminated unions. But even just with records, you can describe these hierarchies. You can have hierarchies of records, as you can with any other class type. And we want to make sure that means something good. And the prototype doesn't quite support it yet, but we know how to do it. It's just a matter of getting the implementation state right. So essentially, what should happen here? So here I have a little hierarchy of nominal records. Obviously, there would be more derived classes from person. So this is just inheritance like you're used to. And I'm now creating a student, but I'm keeping that student around just as a person, using the polymorphism that comes along with inheritance. And now, as I am clicking in the wrong window, as I create another person using a with expression, changing the last name, that we don't want that to now just be a flat person, right? We want it to actually preserve everything else about the original object, not just what I can see from this place in the code, not just the person properties, but the actual studentness of it. The new object has to also be a student. Even if I write this in in a corner of the code that doesn't even know that students exist, that doesn't know about the student class. The object itself needs to be responsible for copying itself to that same type as it had before and preserving the
runtime type needs to be preserved.
So this is a very object-oriented approach to non-destructive mutation, where the object is responsible for its own copying, if you will. Essentially, the only encapsulated behavior of a record will be its ability to produce a clone of itself for change in the with expression. So the other person is in fact also a student here, and it will have the same ID because that's copied over as well. So that's one aspect of it, and then the other record-specific semantics we talked about, namely the value equality. Similarly, dealing with equality and inheritance has always been hard. And now you can't see everything here because I didn't adjust the slides for our heads. But the main point is that if I do like you did before, create an original person that is value equals to the person, then not only are they are still equals even though they're students, regardless, and that equality will actually again compare even. It's a runtime defined equality that will compare even the properties that you can't see, and it will actually, it's a symmetric equality like equality is supposed to be. It doesn't matter whether if you have a person and a student and you try to compare them to each other, it doesn't matter which one you go first with. If a person goes first, it doesn't get to say, oh, that student is like me because they have all the student properties right. It's symmetric, and it will declare a person and a student not to be equal because they have different equalities. So that is all something that we worked out, and that will work just like intuitively as you expect it to, even as you have these hierarchies. This is of discriminated unions of records in C#9. So that's what we had to say about records. That's sort of clearly that's where we spent the most time today, because that is the main feature that probably the biggest feature of C#9. So really giving a big push to value-oriented and immutable-oriented programming in C#9. Now, there are many other C#9 features. A few of them are just mentioned here, and there are even more. But here are a few. Target type new is where target typing is where an expression doesn't need to say a type because the type arrives from the context. And target type new is an example of that, where if I'm obviously creating a person, like I'm passing this to a person argument, or as here assigning it to a local variable, then I don't have to say person. That'll just be inferred from context that you can new up an object like this.
And isn't that a community
exactly
contribution?
Right. So this is one that has been on the docket for a while. It's been implemented by a member of the community, and we're essentially just putting it in because it's great. This is an example of open source actually not just helping us design, but also build the language. We get many contributions, but it's rare that we have a whole feature that comes in like that. But this is a whole feature implemented by a community member. One thing that we're looking at, I think we're still debating the syntax a little bit, but one thing that's sort of missing with with the nullable feature, that it was very important for us that null annotation didn't change the runtime semantics at all, right? So you say I can't take a null here, but the behavior, actual runtime behavior of your code is the same. That means that you still, if you have a public API and you say don't give me nulls, I will blow up, you still have to make sure that you actually do blow up. You sort of have to keep your promise of I will check you for null and I will blow up. And that's still a lot of code, and it's kind of annoying to have to do all these null checks at the beginning of your method implementation, even though you said please don't give me nulls. Just to protect yourself, because they might not be respecting those nullability annotations yet. So we're talking about a feature where that actually does implement those null checks just by annotating them with probably a bang or maybe some other glyph in the parameter list.
I don't want the bang. Bang's not my.
Right,
That's
but
not my
some
vote.
syntax, the
It
important
is
thing is that
contentious.
it's
Yeah.
1 or 2 characters instead of a whole line of code, and this will just throw an argument null
Or
exception
yeah.
if somebody passes in a null. You don't have to write any of that. It'll just give name of the right parameter and off to the races. So really, again, about the simplicity of the code. I don't want half of my logic to just be validation. I want to push that off and get to the actual interesting code. We're also planning to add covariant returns, which means that when I override a method, I can actually tighten its return type to something more specific. And then a caller that knows about this override, they will get a stronger type result, which is very useful. That's something that needs.
This is required for records, right? Because of how we're doing these with
It's not
methods to
required. It's helpful.
manage
It's
these
helpful.
cloning methods. It's helpful. It's helpful. Yes. We don't have to make
Right.
casts.
In general, this is good for situations that you know you're calling the more specific version. They know they're the more specific version, and instead of you then having to cast on the other end, this just gives you the right type out of the gate. So there are many that we run into this all the time.
Yeah.
There are wrong ways and right ways to implement this feature. We've been holding off on it for literally decades because we only had the wrong way, which introduces some brittle bridge method generation in the assemblies. And now we're tinkering with the runtime to actually do it right, so that the .NET runtime simply allows covariant overrides and respects it. And now we can surface that in the language. So if you want to know more, use the previews and give us feedback. First of all, like give us more feedback on what you saw. You can follow C# language design since it's in the open. It's open source. I have some links here. Again, I shouldn't have put the long one at the end where it's hidden. We can go and actually quickly look at some of those web pages. Here is the.
And these slides will be shared, right? So you will have access to these wherever you're getting the video. You also
they won't have the
slides
talking
available.
heads on top of them there. So
yes,
this is the C# lang repo on GitHub, which is actually where we designed the C# language. And you can go and you can see here are reports from all the language design meetings. Here are the proposals for things that are being built, the sort of spec, if you will, for things underway. And under issues is where all the initial ideas and proposals are. So there's a lot, as you can see. If you want to look at the ones that are being discussed in language design, those are the ones that are being championed by a member of the language design team. That reduces the list somewhat, and we can filter further here and look for instance, things that are candidates for C#9. And we're now down to still quite a long list. And these are all the features that are still, it's still a possibility that they make it into C#9.
These are things we're still talking about.
If you want to understand what the status of them is from an implementation point of view, you should go out to the Roslyn repo, which is where the C# compiler is being built, and the VB compiler. And here is a language feature status page where you can see all these features that we talked about and many more, and see what the state is currently. You've seen a lot of them are merged. That's good news. And you can click to see what they're about and look at the implementations and everything. So if you want to learn more, this is a good place to go. Eventually, you'll also want to go to the docs, docs.microsoft.com. It will start to pick up with describing the new features as we get closer to shipping, and that'll be a good place to sort of, if you don't want to see as much of the sausage getting made, but just want to know what's coming out, that'll be a good place to catch up on that. So with that, we're done for today, talking about C# today and C# tomorrow, and it was a pleasure sharing this new kind of build experience with you, and hope to see you next time. Thank you very much.
Yeah. See ya.